The idea behind this augmented reality project is to overlay OpenStreetMap information onto the world in an accurate way so that you can do raycasting to those 3D models, which will then appear like you're doing raycasting to real objects. So this is our first result, and so as you can see, the actual horizon of our world does not match up with the digital horizon, so there's kind of these differences in height, and that has to do a lot with what we actually picked our height to be. So that's something that in the future going forward I have to fix. So overall, the GPS seemed less accurate than I would have anticipated. I was expecting closer to about a 20-meter deviation, but instead it sometimes it was about 20 meters, but sometimes it went up to about 200 meters. Initially for the orientation, I was thinking about using the magnetic field, so picking out the magnetic north that way. I was having some difficulties getting it function with any sort of accuracy, so I just starting my scene pointing north, and then eventually, hopefully, I can get that north pole working again. There's largely three things that I think I have to fix to get this better. So first up, I have to make sure that the North Pole is an automatic thing. So that's something that I just have to work on how that actually functions. The second thing I need to work on is altitude. So I kind of assumed that Saskatchewan was flat enough that I wouldn't have to consider height information, and that is obviously a mistake just seeing from some of the footage. So one of the first things that I fixed is updating the GPS position over time, and that's because the GPS information gets more accurate over time. However, if you're moving your cell phone around, this will actually introduce a double counting in the camera position plus the GPS position. So as you move the phone around, it will add the distance that you moved on the GPS, but it also adds the distance that you moved within AR. So that's a double counting issue that you have to be aware about. So let's just list out what we have to get done and then just try and knock those down as we go. So to start off with, we need to get OpenStreet models, and those we can really easily get from a previous video that I did with GIS information. So we can just get that information, and then we can import that into an AR scene. And if we scale it appropriately, and it isn't currently lined up, so we have to think about how we're actually going to move this model so that it aligns with our actual reference frame. And so the first thing to think about is GPS. And so there's a few different things we can do with GPS, but we need the measurements to be in meters. And so we are going to use an approximation of an arc length approximation. So we're basically just going to say that the arc length equals the length. Next up, we are going to think about how we want to rotate it. So first we're going to do this translation. So we'll translate it to the right point, and then we have to think about how it's going to be oriented, because currently it wouldn't be oriented directly north. And so ideally I wanted to use the magnetic field to do this. I wanted to use rotational matrices and kind of do it that way. But I found that I was running into issues with getting the North Pole to be very accurate. It was getting off by somewhere between like 5 to like 12 degrees or something. It was pretty significant. And this number is very significant when you start looking at objects that are kind of near and far. So it wasn't looking super great. So for now, we're just going to point our phone north when we start the application, and that'll give it kind of an assumption of the value. In this particular model, we're ignoring altitude. And the code for this project was built out of two other projects. So the GIS project we'd previously worked on and the solar system project were both used. So within the GIS one, that obviously was uploading the model and getting the model of Regina. There's a few things that we changed. So we split all the objects up so that they are now independent, whereas before it was just a single mesh. And then we also set their opacity to be lower. So we lowered their opacity so that they can now be see-through objects. From the solar system project, we took the code regarding longitude and latitude and some transformation information. And then we also took the magnetometer code. So that will be used for orientation.